Okay guys, make no bones about it, this is a tricky question. Not only is it tricky because understanding it as to what's happening conceptually is a bit tricky, it's also probably something you haven't really thought about much before. So lifeboats exist on ships, and this is a way for people obviously to get off if there's a problem. Lifeboats look a little bit different to this now. If you go and Google lifeboats, you'll find that they're usually an enclosed boat. But all of them need some sort of mechanism that allows the boat to go from its park position out to overhang the side of the ship to be launched. And the key thing here is one of a pair of gravity davits is shown in the diagram. So the boat is held at both ends by these davits, and we're only seeing one of them because they're behind each other. So the load of the boat, the load of the lifeboat is shared between these davits. So we've got one davit here shown, and the other one is immediately behind it so we can't see. So this is the parked position, it's now rolled down, and when it rolls down these rollers, it sits on this little step here at D. That's what stops it going down any further. So obviously straight away you should be thinking when you look at that, okay, so the reaction at D is going to have a vertical part to it, because there's no other roller there that is impeded from moving down. So that's the only roller that can carry a vertical load. Now we've got the weight of the boat here, so it says one of a pair of gravity davits. It's shown in terms of reaction loads. So the lifeboat has a mass of 1,000 kilograms and each davit has a mass of 500 kilograms. So that means each davit is holding half the boat. So that's 500 kilos for each davit, all at 5,000 newtons. So we have 5,000 newtons there, and we also have 5,000 newtons there. Now, knowing what we know about couples, we need vertical equilibrium if it's going to be in equilibrium, so that's 5,000 down, that's 5,000 down. We therefore need 5,000 and 5,000, in other words 10,000 at that roller at D to balance it. Now, what else happens? Well, if you think about this, when this davit hits D, it's going to there'll be movement in those rollers, and it's going to tend to try and rotate anti-clockwise. Now, when it rotates anti-clockwise, D is going to push up hard against that vertical, and B is going to push up hard against that vertical, because they're going to sort of rotate that way. But that means A and C are actually going to move away from there, because that natural rotation will tend to do that. In other words, A and C are not going to do anything at all. There's no reaction there. So if we were to show this as a free body diagram, you should see I've now drawn 5,000 on the space diagram here, 5,000 there, and I've got the reaction at B, the reaction at D horizontal, and the reaction at D vertical. And remember, as I just said, A and C carry no load, because there would be movement there, and as it rotates anti-clockwise, those two forces tending to make an anti-clockwise rotation, that means A and C are going to be moved away from that vertical member. So if I now look at this free body diagram, I've got 5,000 newtons down there, I've got 5,000 there. Now the reaction at D vertical will actually be 10,000 newtons. But if we can imagine that 10,000 newtons is 5,000 and 5,000, what we have is 5,000 and 5,000, a couple, 5,000 and another 5,000. That's two couples. So I've got the clockwise couple, which is the reaction couple, being balanced by the anti-clockwise couples. And the anti-clockwise couples are 5,000 times 2 and 5,000 times 0.5. So the clockwise couple, the reaction couple, is only a metre apart, so that's RB times 1. So the reaction at B is going to equal 12,500 newtons horizontally. It's the only reaction at B, it's horizontal. But the reaction at D has both a horizontal and a vertical component. So we know that the horizontal component is going to equal to that, because they're a couple. But the vertical component is going to equal 10,000 newtons. So we actually have to add those together vectorially. So what we have is RDV vertical, RDH horizontal. We're going to have 10,000 vertical, 12,500. We add those together, we get 16,007.81, approximately 16 kilonewtons. And we can find the angle to be 38.66. So our final answer for question 9 is RA is 0, RC is 0. RB is 12.5 kilonewtons going horizontally to the right, and 16 kilonewtons for RD, but it's going at 38.66 degrees up and to the left.